In the figure, what is the net electric potential at a point P? What is P? Here we have the P, am I right? And you have four charge particles and all charges are exactly same. So how many charge particles we have? 1, 2, 3 and 4. And for all four charges, it's exactly the same value, 7.5 femtocoulomb. What is the meaning for femtocoulomb? 10 to the power of minus 15. Clear? So Q, which is equal to 7.5 multiplied by 10 to the power of minus 15 coulomb. And here the distance is mentioned. What is the distance? The distance is 1.6 centimeter in terms of meter, which is 1.6 multiplied by 10 to the power of minus 2 meter. Clear? Again, we have to find what is the net electric potential by these four charges at this point P. So again, we have to deal with the superposition principle. I am going to apply this formula V, which is equal to KQ over R. Here R is nothing but, for this question, it is D. Clear? So we have to deal with this formula for each charge. So let's start. So potential net, that means net potential, which is equal to potential for the first charge V1 plus potential for the second charge Q2, then potential for the third charge V3 and potential for the fourth charge V4. Clear? Now I am going to apply the value here. So let's see what is the answer. Okay. So that means this formula I am going to apply for each V1, V2, V3 and V4. Let's see what is it. For first charge we have Q. So K Q over, what is the distance between charge 1 and point P? D. Clear? Likewise, we have to find what is the potential for V2. V2 is here, that is second charge. The distance between the point P and the charge is again D. So you will get K Q over D. And for third charge, again, the distance from point P to third charge is exactly D. So K Q over D. But for the fourth charge, you have to calculate this distance very carefully. What is the distance from the point P to fourth charge is 2D, am I right? So from the distance is exactly 2D for the fourth charge. So K Q over 2D. Now I have to simplify this question, simplify this equation. So I'm going to take 2D is the LCM value, 2D, and here you will get 2 times of Q. I'm going to take a common term K outside. So 2Q plus 2Q, and here what is the potential? Okay, here I forget. What is the charge here? We have negative charge, am I right? So that means this one is negative Q and also this one is negative Q. Clear? So here we got a minus 2Q and here we'll get only minus Q. Why? Because here we have 2D already. So this plus 2Q minus 2Q get cancelled, and if you simplify this, you will get only Q. Am I right? So K Q over 2D, substitute value. K value is 8.99 multiplied by 10 to the power of 9. Charge value 7.5 femtocoulomb. 7.5 multiplied by 10 to the power of minus 15 divided by 2 multiplied by D, and the D value already given in the question as, what's the value of the D? The D value is 1.6 centimeter. Am I right? So we already have to convert 1.6 multiplied by 10 to the power of minus 2 meter. So our net potential for these four charges at a point P is given as 8.99 10 to the power of 9 multiplied by 7.5 10 to the power of minus 15 divided by 2 multiplied by 1.6 10 to the power of minus 2. So I got 2.107. 2.107 multiplied by 10 to the power of minus 3, and the unit for the potential is V. So this is the answer.